Today let's go through this Pascal's triangle problem together. And firstly, let's go through the problem description first. So we will be given an integer which represents the number of rows, and we will need to return a two-dimensional array which represents the values in the Pascal's triangle. And the Pascal's triangle is really like a Fibonacci's problem, and it has a rule that dictates the evolution of every row. And this problem is basically a simple dynamic programming problem, and we will need to derive the next row according to the previous row. So let's start dealing with this problem. Firstly, if n equal to 1, if num rows equal to 1, I will return 1. And if num rows equal to 2, will return 1, 1, 1. And we will always know that the num rows will be equal to or larger than 1, so we do not need to consider the case when num rows is equal to 0. And then, if num rows is larger than 2, we will define a result array here, and we will define we will add the first and the second row into result array first, since the first and the second row does not follow a rule. And we will define previous row as 1, 1. And then we will try to derive the third row according to the second row. And we will and the rows that we need to derive are from 3 to num rows. Yeah. And for each row, we will derive the row according to the previous row. So we will firstly initialize the row to 1 times I. Actually, I make something wrong here, so I should start from 2 instead of 3, because, for example, in this example, we will derive our row from this position, and in this position, I is equal to 2, and we will end after we get the row at this position, and at this position I is equal to 4. So I should actually be in range 2 to num rows. So we will initialize a row first, and the row should be 1 times I plus 1. We will initialize it to 1 times I plus 1 because the first element and the last element of the row are always 1. So we just initialize the row to 1 times I plus 1, so that afterwards we do not need to update the value of the first and last element of the row. And then for j in range, we will start from 1 and we will end at I plus 1. At this time, row j will equal to previous row j minus 1 plus previous row j. Oh, I think I made a mistake here. The ending point at range should be I, since we would like j to end at I minus 1, by this sentence, I mean that when j is equal to I minus 1, we also would like to get the value of row j. So we will put I here inside range. So that's it. And after we go out of the loop, we will append row to the result, and then we will update the previous row to row, and finally we will return result. And let's run together. It is accepted, and let's submit. So the time complexity of this algorithm is O(n)², because we have a nested loop here, and for the outer loop we iterate through we iterate from 2, 3, 4 to approximately num rows, and inside the outer loop we have the inner loop, and for each element I, we iterate from 1 to I. So the final complexity should be 2 plus 3 plus until num rows, and this will be O(n)². And space complexity will be O(n). We will not count the result into space complexity, since the result is the output, but instead we will definitely need to count this previous row and this row into time complexity, and these two variables will take O(n) space complexity. So the total space complexity is O(n).